I'm going to start with, what's the biggest gap you see between companies that are experimenting and companies that are actually starting to find successful deployments in production? What are you seeing as a big characteristic differential?
Yeah, for AI and deployment.
For AI in particular, yeah.
Yeah, I'd say, look, I think one of the challenges that many companies had is that when they started doing a bunch of proof of concepts with AI, they didn't actually have good success criteria defined at the beginning. It was just kind of a learning journey. So, and I'm sure many of you went on this, where you asked your teams to do hundreds of different experiments and to roll them out, and you didn't really have a goal of what you were going to accomplish. And I think knowing what that is, and helping define that is one of the first steps of really understanding kind of which of those things to move to production. I have a fun example. I was at the JP Morgan Health Conference a couple weeks ago here in San Francisco, and one of the big things that people were excited about was ambient listening, where you could have a bunch of this AI that would listen to the doctors and it would automatically put the doctor notes into Epic and automatically send the information and things off to the insurance companies, and people were very excited about it. And I met with one hospital leader who was like, yeah, I did all of this stuff and it's great. And the doctors have more time at night to have dinner with their families. I haven't saved a single dollar. So like, what am I getting out of this? I've like literally have not fired a doctor, I haven't saved anything. Not like 2 hours later, I met with another hospital administrator who said the exact same story, said all these things are happening, it's great. And he's like, and I was really worried about attrition. Like my doctors, I was gonna have like, there was risk that 30% of our nurses and doctors were gonna attrit in the next 12 months. And now they have a lot more free time with their families and that attrition number has gone down. So I'm super excited, I'm rolling it out around the hospital. And so having that metric as to like what the real thing and the value you want out of that, I think is a huge thing that blocks a bunch of companies, because they initially say, I'm not saving any money with this thing. And that may be true, but it may also not be the goal.
And do you think, like, what percentage of companies do you think have good solid metrics that you feel are at the right level at this point?
I think, I actually think it's oftentimes by the area that they're rolling it out. I think when people are rolling it out for customer service, great. People usually have quite good metrics there. I think when people are starting to roll it out with code, as an example, which I heard you guys talking about earlier, lots of metrics there, right? Lines submitted and things like that. And for the rest of the workforce, where it's kind of a general productivity fuzzy metric, I think people don't really have a good sense there.
Yeah.
And so, I think and we'll get there, by the way, but I do think that that's part of it. I will say the other thing that blocks people from rolling out, and this is a more fundamental piece, which is, and this particularly gets into agents, which is as you get into agentic workflows, people are super worried about security. They're worried that the agents are going to go off and do things that they're not supposed to. They're worried about the sprawl of agents. They're worried about agent identity and a bunch of those things. And frankly, they're worried about how you scale, right? They worry about, I did a proof of concept, so I went and bought like one EC2 instance with GPUs on it, and I tested it. And now I want to roll it out around the world. Sure. Like, that GPU is relatively underutilized. It's, it's how do I scale this? How do I think about that? So I think just that general like productizing a proof of concept, people haven't really got their hands around how to go do from a security point of view, from an operational point of view, from a scaling point of view.
And if you folks have been talking a lot about this notion of AI first cloud. What does that actually mean? Talk to us a little bit about how AWS is thinking about it.
Sure. Well, look, there's, I'll take a half step back. We view that AI and inference in particular is going to be a critical part of every single application in the world. And so there's not going to be AI applications and non-AI applications. There's going to be applications, and they all are going to have inference integrated into those capabilities. And it's going to change every business, it's going to change every industry. And so what that means from our perspective is, that means it has to be integrated into every single piece of the AWS infrastructure. And you've got to have, you have to be natively thinking about how can AI and your agents talk to your storage? How is it going to work inside of your VPC and your security settings? How are you going to think about permissions? How are you going to think about trade-offs and testing one model versus the other once it actually gets to production? And so we're building a platform which is called Bedrock, but the idea being which is that we want this real platform that's going to have a ton of model choice, a ton of capabilities, and all of the security that our customers expect inside of VPC to be able to roll that out. And then we supplement that with, we have this observation that all of the biggest other partners in the world kind of operate inside of, and on top of AWS too. And so we open that up and make sure that every partner and every part of the AWS ecosystem can be a big part of what customers are building, because we don't think that we're going to build every part of that, and we know customers need that whole ecosystem to be successful in what they go and build.
But you are building one of the very high-margin products in that stack, which is the Trainium chips, which have actually seen a tremendous amount of success. Congratulations on that.
Thank you.
Do you see the economics of AWS changing where the margin structure gets even better? Because if every application has inference and you're going to have inference capability on in the stack that you have built out, does that improve your margins over time?
I have no idea. That's a good question. That's for the bankers to guess on. But I will say it definitely, I think it improves our margins versus only using NVIDIA GPUs. And they're always going to be a big part of that, but necessarily a big part of that margin goes to Jensen and the team. And we love their products and they execute awesome. But when you have 70%, 80% gross margins, there's room in there for somebody to take less margin, have a higher performing part, and offer choice to customers. And so we think that we can offer better price performance for customers, choice for customers so they can pick between the various options out there, and have the richest set of capabilities that are unique to AWS that they can't get anywhere else. And that's part of why we've invested in silicon for the last 10 plus years now, and it's such a big part of what we deliver, which is that differentiated performance all the way down to the silicon layer, which together with our partners offers a really rich set of capabilities that people can build on. And I think Trainium for us is a huge part of that, whether it ultimately allows us to increase margin or keep margins where they are and lower prices for customers. Frankly, I'd probably bet on the second, because that's just how AWS operates.
Is wired,
So my guess is it's probably more that, which we try to grow faster. And because we find that every time we lower prices, generally we pass them on to customers, and it gives customers more budget to go build new workloads. And for us, that generally leads to a good flywheel.
The Jevons paradox is kind of in full-fledged. So, okay, so let's talk about constraints on infrastructure build-out. You and I have talked about this. You talked to a bunch of hyperscalers. One of the challenges that they have is that it's not just about capital being allocated. It is literally physically very time-consuming to build out the shell, get the permits, have the power, make sure that you have the entire stack getting built out. Does space data centers change the equation? And do you think space data centers will actually take away some of those constraints? Because solar is going to be 30% more efficient in space. Do you see that happening, or do you feel like we're still pretty far away from that?
It all depends on your timeline for me. So you're right. Look, a big chunk of this is just, it's hard. Like going and building some of these things are actually quite difficult. And it turns out that people are very excited that they can build software in a fraction of the time, but pouring concrete takes the same amount of time, and building buildings takes the same amount of time. We haven't yet built AI agents that can do that. Maybe the robots will eventually. But for space data centers, I think there's a lot of compelling ideas about a data center that's in space, right? Infinite amount of power that's always available, great. Easy cooling, that's great. I don't know if you've seen a rack of servers recently. They're heavy.
1,000 pounds.
The last I checked, humanity has yet to ever build a permanent structure in space, on the moon or anywhere like that. So maybe, but I know Elon says he's going to launch 1 million satellites or whatever. There are not enough rockets to launch 1 million satellites yet. So we're pretty far from that, and I think there's probably going to have to be some improvements in the efficiency and the cost. If you think about the cost of getting a payload in space today, it's massive. It's way more. There's no way it's.
Blue Origin might actually come in handy there.
It would be great, but they have to get their costs way down. It is just not economical today. So I think there is an interesting, depending on where that cost curve goes, they're probably going to find some cheaper rocket fuel. There's a bunch of things, and there's a huge number of people that are investing in making space transport much more economical. But that's a ways off. So.
And then that does become a huge bottleneck in space, is just the transport.
Just the transport.
Itself.
I mean, it's absolutely, that is the bottleneck today, is the cost and availability of just getting things into space.
Getting things in space. So let's stick on Earth.
Probably some latency concerns as well.
Yes, slightly farther. But so let's stick with Earth data centers for a second. Do you think that the definition of full stack for hyperscalers changes? Do you start getting more into the power business? And do you get into more of the construction business because it feels like if you control the full stack, would you be able to accelerate this faster?
Well, look, I'm not the best person to ask this because if you asked me 20 years ago if AWS would be making chips, I definitely would have told you no. But here we are, and I think some of it is necessarily the answer will be yes, actually, almost for sure. And it's because if you look at the economics of a number of those different industries, they don't scale with the level that we need them to scale, right? Utilities, as an example, have for almost the history of time, they have fixed pricing, right, and regulated pricing, which is a limiter to them, and they get fixed return on their investment. So they really are just the whole industry is constructed to grow at 3 to 5% a year. And it's very hard to break them out of that because why would they go take a risk when they get low returns on that and other things like that? And so either, and whether we own the power or we fund the power, like I don't really want to operate data like power stations or things like that definitely is something I would like to not do. And the whole system is much more efficient if it can be connected to the grid. And there's probably some steps between here and there where you're going to have to do behind the meter power and other things like that because it's just, we're going to have to fund that ramp up while the world catches up.
So staying on that topic for a second.
Or we'll rely on people like Turek to do it too. So.
Yes, of course. So let's say that you continue to make sure that you're building out the chips. What's the average cycle time of chips now that you have? Every 18 months you're getting a new version of the chip out?
18 to 24, it depends.
But that's compressing.
It sometimes is compressing, generally. But yeah, call it somewhere between 18 to 24 months.
Right.
Yeah. But sometimes you're also limited on your process kind of generations.
Yes.
And things like that. So it's you're also limited on how fast does TSMC kind of improve process generations. You're also limited on just how fast you can actually get these systems into production. Like they actually, from the time you print your first chip to when you're really at scale for these really large AI systems, like it actually is like 9 to 12 months from first chip out to really, manufacturing actually is quite hard.
But in general, you would agree that the cycle time has compressed more over the course. How do you do capacity planning at the scale of AWS? And does that equation change a little bit? Like, for example, you don't want to have a bunch of chips that you bought that in 18 months become obsolete, but you have to make sure that there's a long tail on how different workloads start using them. How does capacity planning work?
Yeah, there's a couple of things that play in our factor. Otherwise, it's a challenge, and it's part of the challenge that we take on, so customers don't have to take that on. There's a few things that play in our favor there. One is because there is so much more demand than supply, there typically still is demand for the older chips, actually. And today, we actually are completely sold out of and have never retired an A100 server, as an example. So completely sold out. Now, by the way, there's also structural reasons for that. If you look at
You've never retired an A100 server?
I mean,
that's what,
like
besides it going bad.
Fail or something like that. Yeah, but outside of that, no.
That's
because there's still demand for it. And there are some structural reasons why every next generation, right, part of where the industry today is getting so much gain on the AI side is reducing the floating point accuracy, right? So I was actually talking to some customers recently, and they were saying, like, actually, I can't move to Blackwells. I have to use Haswells because I'm doing kind of HPC-style calculations, and the precision is not enough for me. So actually, they're kind of in a hard place where actually the AMD new processors are still kind of, you can enable that. But a lot of the world actually, and some of the old applications rely on that level of precision. And so there's, anyway, and there's use cases for them. Smaller models still run great on A100s and other things like that. So I think there's a long way there. And for some of these large labs, they're also willing to take 5-year commitments for some of this capacity sometimes too, which also mitigates some of our risk and pushes it onto customers potentially. But there's that. But there's, like, we do a lot of planning here. We have to think about, there's many time horizons that we have to plan for. So take, for example, in the last year, we added just south of 4 gigawatts of new capacity in AWS. For the data centers, data centers are a 20, 30-year amortization timeline. The power, you have to make commits for long periods of time, et cetera. And so you have to both think about how are you thinking about data center planning for a really long time, because I'm going to have this asset for 20 years or 30 years, And you think about servers, which you have for 5 or 6 years. You have networking gear that's maybe 6 to 10 years, like different components. You have to think about all of those. And so we spend a ton of time thinking about supply chain and thinking about how we think about risk levels at all of those levels of investment.
Okay, let's switch to AI coding. You and I had talked last time I was in your office, and you were saying that you're seeing some pretty great, kind of results from that internally.
Yeah.
Talk to us about what you're seeing working well, what you're seeing not work so well.
Yeah, we see, I would say in particular, the thing that we see that is giving massive acceleration, and I would say, 10x improvement or more, sometimes 100x improvement, is when the teams start from the beginning thinking about AI-driven coding. In fact, we have teams now where they have almost a mandate that they write no line of code. All they do is they prompt the models, or they prompt the systems. And that there's a couple of benefits you get from that. One is the AI systems build a ton of context around what they're building. And then they also know how all of those things work together. They've also documented all of the code that's written, so you will start to get like a real flywheel where it can then test all of the code because it knows the documentation, it knows the things it needs to test, et cetera, and it has all of that coverage. I will say where we're not there yet, and it's a yet because it's probably within the next 6 to 9 months we will solve this problem, is that we have not yet seen that speed up for really complicated integrated legacy systems, I would say. And they're not necessarily legacy in the sense of mainframe, but even like a really large distributed system that has a large code base. Say something like S3, which has been around now for a little bit of time. We've reimagined it many times before, but it's not zero. We're not starting from scratch. And so giving all of that context to the models and so that you can get that same speed up. We still see some speed up, but not quite the 10 to 50x speed up. But I think we're building and thinking about some novel ways in which we can get coding systems to understand legacy code. And I think that's one of the areas that can help people start to get massive speed up, which turns out most of the code is legacy code out there.
We're actually seeing that the further down in the stack you go, the harder it gets.
Yeah, and it's that probably too.
Yeah.
And that S3 is another good example of that, where you're really thinking about like
memory management is much harder to do.
Memory management and correctness of durability of objects and things like that is a little bit different than end user application where it's like build me a website, which the agents are quite good at doing now.
Hey, so when you start thinking about like sovereign AI infrastructure and how countries are going nationalistic, they each want to have their own infrastructure. Do you think like architectures like Outpost get even more interesting?
They are. I think. Look, I think this is a super interesting topic, and I was just at Davos 2 weeks ago, and probably nearly every single conversation I had with a European company started with like, look, we trust you. I don't know if I can trust your country, and we try to like walk them through like why that's not really the trade-off they should think about, and they also realize that they can't tie their own hands behind their back and not compete with the world's best technology. So these companies are realistic, but they're having the struggle. And I don't know how many times I literally had the question of like, how do I, what if the U.S. government decides to turn me off? And it's a question that many people have, and we assure them like that's very unlikely to happen, and it's a concern they have. And so
resilience almost trumps raw intelligence at some point.
Yes, in some ways, right? And if you think about banking systems or you think about telcos or other areas like that, where they just, from a country perspective, the countries feel like they now need that lever, or they're at risk of us being a lever against them. And so we're thinking about a bunch of different mechanisms to solve this around the world. Just 2 weeks ago, we launched the EU Sovereign Cloud. And I think for EU, this is actually going to be a fantastic and then your partners, they're launch partners, so thank you.
Yep.
But the EU Sovereign Cloud, the idea being is that it's a fully separate subsidiary that is incorporated inside of the EU, beholden to EU laws, actually has an independent governing board, and we make sure that every bit of data, including metadata, including account logins, all of that lives inside of the EU region. And we've even tested disconnecting that whole region from the AWS backbone to make sure that they show. And we actually co-designed this with the BSI from Germany and other EU countries to make sure that they like this model. And I think that works for EU because it's such a large economy in and of itself. But I think we are exploring with a bunch of different things like that to help a bunch of companies around the world grapple with this, where there's obvious trade-offs, but it's hard questions. But hopefully that's where we can help.
Matt, 30 seconds or less, can you provide the CIO and the CISO audience some advice on what they need to do to accelerate AI adoption internally?
Yeah, I think, look, I have this analogy that I like to use that if you have a giant canyon and there's a board across the canyon, you walk really slow across that board, right? Like really slow. You maybe crawl across it. Now all of a sudden, if you like put handrails up and you put like walls and guardrails, you can run across it. And it's weird because it's like the same board. Yeah. But you can run across it and you can do it. And it's not that dissimilar. Like you need to have, like part of what slows people down is they're worried, right? We had examples internally where somebody was writing some code and they asked the agent to go do something. And the agent was just about to go like delete some infrastructure because they thought that was the fastest way to do it. And like, no, like that will actually cause like production issues if you go do that. And we have other controls, so that wasn't the case, but it was like, it highlights like, I think lots of companies are worried that if they just unleash agents into their enterprise, bad things will happen, production will go down, security issues will happen. And so what I would say is what we're trying to do is build building blocks for customers so that they can go fast, right? Things like Agent Core are for us allow you to have some of these guardrails that allow you to go fast. And the more you can give your teams safe places to run fast in a production setting, I think you'll benefit.
Matt, come back again.
Awesome.
Thank you again.
All right, thanks, Jeetu.
Thanks so much.